Assalamualaikum and good morning. Today our group will be present plant watering system for our mini project. Now I will introduce our team members. For leader Adam Muhammad Akil, and the other member is Ahmad Azam, Muhammad Amirul Faiz, and lastly Dania Adriana.
Good evening, everyone. Today I want to talk about a crucial challenge facing agriculture and how technology can transform farming into a smarter, more sustainable practice. Agriculture is the backbone of many economies and essential for feeding our growing global population. However, farmers today face significant challenges including climate change, limited resources, and increasing demand for food. Traditional farming methods often lack the precision and scalability needed to address these issues. Thanks to advancement in information technology, farming can now be smarter and more efficient. Innovations like the Internet of Things (IoT), artificial intelligence (AI), and cloud computing allow farmers to monitor crops in real time, optimize resources usage, and make better decisions based on data-driven insights. Our proposed smart farming system integrates IoT devices, predictive analytics, and automation to help farmers improve crop yields and manage resources more effectively. By combining modern technology with traditional farming knowledge, this system aims to support farmers, enhance productivity, and promote sustainable agricultural practice. In conclusion, adopting smart farming technologies can drive agriculture into a new era of efficiency and sustainability, ensuring food security for future generations. Together, we can empower farmers with the tools they need to overcome challenges and cultivate a better future. As you can see in the slide, the objectives of this mini project is to develop and implement a smart agricultural system that enhances crop production, optimizes resources management, and supports sustainable farming practice. And also, its secondary objective is to apply precision farming techniques using data analytics, and AI for better decision making in agriculture. To design and also to design and build efficient irrigation system then that conserve water and boost crop productivity, particularly in arid regions. Water is a critical resource in farming, yet traditional irrigation methods often lead to overuse, waste, and inconsistent watering. This project presents a smart irrigation system designed to tackle these challenges with automation and real-time monitoring. Our system uses a soil moisture sensor connected to an ESP32 microcontroller to continuously monitor soil conditions. When the soil becomes too dry, the ESP32 activates the water pump, ensuring the plants receive just the right amount of water. Once the soil reaches the ideal moisture level, the system automatically shuts off the pump, preventing unnecessary water consumption. To further enhance usability, the entire system is remotely monitored and controlled via the Blink app, allowing farmers to manage irrigation efficiently from anywhere. This intelligent approach to water management optimizes resources, boosts up crop health, and supports sustainable agriculture. By integrating IoT technology into farming, we can reduce water waste, improve productivity, and empower farmers with data-driven insights.
So now we move to how watering process flow. The soil moisture sensor continuously checks the soil's moisture level and sends data to ESP32, which automatically activates the water pump when the soil is dry and turns it off once optimal moisture is reached, ensuring efficient irrigation that can also be monitored and controlled. Next, sensor function. First, measures the voltage level corresponding to the moisture content in the soil. Second, when the moisture level drops below a preset threshold, the sensor sends a signal to the ESP. Third, the ESP then activates the water pump to irrigate the soil. And lastly, This smart control helps to avoid overwatering and conserve water, making it ideal for sustainable agriculture and home gardening. That's all. Thank you.
So, for hardware component, we choose ESP32 for our microcontroller. It's the brain of the system that connects to the Wi-Fi on our mobile phone. Number 2 is soil moisture sensor. It measures how wet or dry the soil is. Number 3 is water pump. It delivers water to the plant when the soil is dry. It turns on or off based on command from the ESP32. Number 4 is relay module. It controls the water pump using signal from the ESP32. And lastly, power supply. It provides power to the entire system, and we using the battery for our setup. For circuit design, soil moisture sensor VCC connect to 3.3 voltage on the ESP32 and ground to ground on the ESP32. Connect the AO pin of the sensor to the AO pin on the ESP32. For relay module, we connect VCC to 5 volt and ground to ground on the ESP32 and connect in pin on the relay to a GPIO pin on the ESP32. For operation, moisture detection, check if the soil is wet or dry. If the soil is dry, it sends a signal to the ESP32. The ESP32 reads the moisture level and decides whether to turn on the water pump. If the soil is too dry, it sends a signal to the relay to turn on the water pump.
For the working principle, the soil moisture sensor monitors the soil and sends data to the ESP32. The ESP32 checks the moisture level and, if dry, triggers the relay. The relay powers the water pump, which will water the plants and soil. Once the soil is adequately wet, the system stops the pump. This process ensures that the plants get water only when needed, making the system automatic and efficient. In conclusion, this smart irrigation system simplifies plant care by automating watering. At the same time, it will save water and improve the plant health. This system is suitable for gardens, farms, or educational projects because it combines technology and sustainability to make gardening and farming more efficient. This system is a practical step toward eco-friendly agriculture. Lastly, for the recommendation, we can use automated irrigation based on sensor. This system will automatically activate the pump if the soil moisture reaches the soil is too dry, and it will automatically turn off the pump when the sensor detects the soil is too wet. The system can help optimizing the water usage. We can also use we can also receive alerts and notification on our phones from the application. Thank you. This is the demo for our group project. As you can see, the moisture level on the phone and the LCD displays are the same because the soil moisture sensor is a bit wet because of the soil already wet, and switch off. That's all for our group. Thank you.